Welcome to the Building in Decentraland video series. These videos are recordings of the live sessions of the inaugural class offered by the VR Academy, which is a school within Decentraland University. My name is Carl Fravel, and I'm the instructor of this course. These videos are largely unedited recordings of the live class sessions. The descriptive text provided below this video includes information about Decentraland, a virtual reality on the blockchain, the Decentraland University and its schools, including the VR Academy, and the course materials for this course, including the lessons and assignments. I hope that you enjoy studying these materials and that they help you to become a very capable builder in Decentraland. Welcome. Can you all hear me? Good. All right. Thank you. Looks like we have 7 people on today. It's good attendance. I'm going to start it with a usual thing of any questions about the previous assignment. It was a little complicated, and it's going to get more complicated here in number 9, so I want to make sure any questions or issues are resolved as quickly as possible. Assuming we'll go ahead, but as usual, if you have a question that arises while we're going, don't hesitate to jump in on the chat or by voice. I don't mind this being interactive. Okay, so lesson 9. We're going to be doing a number of things, kind of a multidisciplinary experience. To complete this assignment, you're going to have to use all the skills that you've been learning and probably figure out a few additional ones. I'm intentionally pushing the edge a little bit about having you figure out how to do things that haven't been covered by going to the documentation on Decentraland or on Blender or on TypeScript or whatever you might need. I'm trying to create kind of a real world experience here in lesson 9 of all the kinds of things you have to face when you're doing a real project, including having to figure out things that are unknown or that are difficult or maybe broken. Occasionally, Decentraland has some broken things. Right now, their animations are broken, at least in some cases. I also want to share some news here. It's not widely public yet, but since you are here, I'm going to share this with you in that there's a new release of the Builder coming out very soon. I was told Monday, but you know how things are. It might be a little later. But it's testable now. And I'm going to give you the URL to it. It's instead of builder.decentraland.org, it's builder.decentraland.zone, Z-O-N-E. And it has a few really nice improvements. Number 1 is you can size things now in the Builder. This is the first time you've had a size icon. The second thing, and at least as exciting, is you can now put your own assets into a custom asset collection. So you can add new things on the right side where the collection of assets are. Those assets are stored in the cloud, just the same as your scenes are if you're logged in. So you work on one browser, you go to another machine and log in as yourself again, and you'll find your assets. But they are private to you. They're not visible to somebody else. So those are the 2 big additions. It seems to have a little bit better integration with the login, log out capability. I don't think you could log out before if you wanted to change your identity. So anyway, there's a number of improvements. I know they're still working on improving it further. I've given them a bunch of feedback, and what I was told is all those things are on their working list to try to get them done by the time they release it. So it's very good news. Doesn't mean you don't need the Builder HUD, but you don't need it as much because you can size things and move things around, put your custom assets in the Builder. However, once you're working in the SDK and you started making changes to your script, you can't take that back. You can go back to your original scene and put a few more things in it and use that as a reference to copy some code from the new scene into your working scene. But the Builder HUD still is useful for moving things around and resizing them and positioning them very accurately in the SDK. So that's news. Also, I want to reiterate that anybody that is considering participating in the game jam, either solo or with others here, please do. It will be a great way to learn and to work together on a project. And if it seems to be interfering with your work on this class, give priority to the game jam. It has a hard deadline. Sometime on September 30th. The exact time would be announced by Decentraland. but it would be an opportunity for you to work to a deadline, to work with other people, to try something you haven't tried before. Their Game Jam materials have a bunch of suggestions for ideas of things to work on. So, all right, so let's delve right in. I've been working with Blender on and off for a few years, but I would not consider myself an expert in it. But I've been keeping notes of the things that I've been learning that are kind of maybe hard to remember sometimes. I've linked the URL to my personal collection of notes on Blender at the top of lesson 9. Feel free to look at it, put comments in. If you figure out something hard, I'll be happy to add it, put a comment in or whatever. I don't consider that document kind of prime time as much as I say that the transparency document. It's more kind of just halfway cleaned up, let's put it that way. And it has a long section in it that I've just put in the last couple of days about the sequence of things you have to do to animate a mesh. How do you build a rig? How do you attach the mesh to the rig? How do you weight different parts of the mesh to different bones in the rig? How to fine tune it, and how to make animations, including multiple animations in a Blender file. However, note that until they fix the animation bug, you might not be able to use the results of that work in, say, the Game Jam. I'm not sure, and they're not sure yet. I've sent them a test file that has a simple animation that doesn't work, but works in Babylon JS. It works in Blender. So they have something to test. There's other animations that do work just fine. So I'm either they or I figured out quite what it is that is the issue. It's either a bug in Decentraland or something that they're not going to support or don't support yet. And we'll figure it out. But anyway, feel free to look at my Blender notes and maybe add any suggestions you have to them. There's one thing in there that's literally a quote from part of one of the chats that happened in this class. So it's just a working document. I want to, starting on the today's lesson, just kind of work through the materials, and then the lesson today could go long, maybe an extra hour, depending on how long it takes to get through both the lesson and I'm going to try to work through portions, at least, of the assignment so that you kind of see some of the complexities involved. I'll probably leave a few things as homework, not answered, not resolved, but I want you to kind of see what's involved. So a good portion of the lesson materials have to do with materials today. So let's dive right in. Materials are what affects the way that light bounces off of or interacts with the surface of an object. Materials apply both to, the concepts of materials apply both to primitive objects and to GLTF files. When you're working with a primitive object, you adjust the materials in script. If you're working with a GLB or GLTF mesh object, you adjust the materials in your 3D modeling tool like Blender. So materials affect things like how shiny the surface is, how rough it looks, whether the surface is transparent more or less, whether it appears to emit light. And those various factors apply both to primitives and to mesh objects, but you do them differently. But the concepts are very similar. Primitive shapes have two types of material systems in the script, basic materials and materials. And I've always used materials. There may be some advantage to the basic materials, but I'm not aware of what they are. So in this course, all the examples are using regular materials. And let me also talk about what a texture is. The surface of an object can be defined in a material as like a color or a transparency level for the entire thing. But you can also instead use an image file to control how that might differ over the surface of the object. The most obvious example of that is using it for the color setting. If you push a texture of a photograph or of a painted variable surface. If you put that onto the object, well, then that object takes on that look like wood or stone. And that is done using a texture image associated with the material. And in addition, you can use an image file to control other aspects of the material, such as the roughness. You can have part of it be rougher than another part, or the emissiveness. You have light come just from one part of the object, etc. So texture file, normals. Let me just mention normals. They're worth understanding. One of the ways to more efficiently simulate that a surface has texture, that it's three-dimensional, is to fool the eye of the beholder by controlling the direction that light reflects off the surface. A simple object with no material definition, the light reflects off at the same angle that it comes on. It basically, the reflectiveness of the surface is perpendicular to the surface. But you can tip that angle using using normal map. And when you do that, then at least when you're looking at it face on, it looks pretty textured. It fools your eyes. It doesn't fool your eye if you get around and look right down the surface, straight down the surface, then you see that it's flat. But it's a lot less expensive in terms of triangles than actually making the surface rough. So normals are an important thing. And when you get a collection of textures, like if you buy them or something, you'll often get both the color map or the albedo texture map, but you'll also get the normals map. And you'll recognize it right off because it usually looks kind of purplish magenta. And so if you see in a collection of images that one of them is kind of purple mostly, then you know that's a normal map and it's used in a little different way than the color map. There's various things, various kind of topics or techniques you need to understand when you're working with materials in a mesh object. One is the concept of shaders. Shaders are, at one level, you can think of them as little pieces of software that run in the rendering engine that guide or participate in how the surface looks. And shaders are developed usually in a way that they're implemented in your graphics processing unit, GPU. But in something like Blender, they're visually represented as like a little property sheet with inputs and outputs. And you assemble the appearance of your material in Blender by creating a network of these nodes. We're going to see some of that. Let's talk a little bit about UV maps. UV maps are instructions on how a texture image should be applied to the surface of a mesh. Obviously, if you have a complicated mesh and you have a square texture map and you just kind of squeeze it onto it somehow, it's probably not going to line. How do you line it up? What parts of the image go on what vertices of and what faces of the mesh? And that's where a UV map comes in. When you're working in Blender, a UV map looks sort of like a 2D image overlay on the image. It's overlaying kind of a wireframe of the mesh stretched out over the image. But the UV map is actually stored in the mesh, in the vertices of the mesh. It's not a 2D object. It's additional 3D information in the mesh about how an image should be applied to it. The reason it's called UV is that it's 2 additional coordinates on each vertex. So each vertex has a three-dimensional X, Y, Z to say where in space it is, and then 2 more coordinates, U and V, to say which pixel, U and V, 2 coordinates in the texture map, left, right, up, down, which pixel would go on that vertex. I'm slightly oversimplifying it, but that's the idea. And the UV mapping system causes the rest of the image to be interpolated between those points on the surface. Maybe we'll get to demonstrate one of those today, but that's what those are. And there are tools in Blender, by the way, for building a UV map or working with one. Most models, when you buy them, will come already with a UV map. Somebody's already done the work of defining how the surface of the object should be mapped so that then you can create a texture more easily that goes onto that. And for simple objects like the Blender cube, the UV mapping is very simple and somewhat automated. For really complex shapes, there's some automation. You may need to do a little bit of work on it to get it to map. I think it's time maybe to dive in a little bit. Let's bring up Blender. Well, here's a box. If I go to shade, it's like has no material on it. And you can tell that by, and I lied, it does have a material, a default material. How wonderful. If we want to see what that material, how it's built, we go to the shading tab, sorry. And Blender is now pretty interestingly compatible with Decentraland, or the other way around, because it seems to prefer when it has to make its own call about how to build a material nodes pattern. It tends to default to or prefer using the principled BSDF shader, which is a shader that has a heritage going into Disney, as I understand it. It's a pretty modern shader, and it has lots and lots of different settings, as you can see. When you import GLB or GLTF or an FBX file, or foreign files into Blender, if the thing coming in doesn't specify which shaders are being used in a way that's compatible with Blender, then Blender will make up a material that's compatible, and it will be centered around the use of the principled BSDF shader, which is really nice for us because that's what Decentraland uses for the most part. These are called nodes. We're using nodes in here. If we turn that off, there's a simpler materials pattern, but we're not using it. And some of the nodes are shaders. The shader nodes are green. And then there's other nodes, like you have to have the material output node in here, because all the things that may be in a nodes map or nodes graph or this diagram eventually flow into the inputs to this node, which is what actually gets put on the surface. You won't see the effect of the material on the surface unless you're either in the look dev or rendered. The new 2.80 Blender has a very fast, very high quality renderer in it called Eevee. Used to be you'd have to wait for a scene to render to know what it would look like when rendered. And now they have a renderer that is performant, rather like the one in Decentraland or Unity, that can be used in real time. So the difference between the look dev and the rendered is not a lot of difference in appearance. They both make use of the nodes. The material one might just perform a little faster. But if you are on the solid, everything is just gray. If you're on the wireframe, you're seeing just the mesh structure. So I usually work either in look dev or right in the rendered one. Let me show you kind of what the effect is of messing around with this. So for example, I'm going to disconnect the output of the shader from the material output, and the object becomes black because there are no instructions on how light should reflect off it, so it doesn't. This is basically how you work with this thing. Now, if I want to control the color, I can control how bright or dark it is. I can control the color of it. And you have several different ways of representing it numerically: RGB, or hue, saturation, and value, which means brightness. You can also use the hexadecimal codes. If you've gotten a hexadecimal code from someplace about a color, you can just put it in here. The first two digits represent red, the second two green, the last two blue. The hexadecimal is 16 base, so 2 digits of 16 is 0 to 255 for each of these, which is one way of representing RGB. In Blender, most values like this are represented as numerical values that go 0 to 1. That's very common. So if I grab this and slide it over to the right, the thing gets redder. Slide these down as pure red. You know, if you combine red and green, of course you get yellow in light. If you're red and blue, you get magenta, etc. There is an alpha channel also, which controls transparency, but that's not how you get transparency here. we'll talk about that. There's a couple of shaders you have to add to get transparency or emissiveness, because the way at least Decentraland works, it doesn't use those things from here, from this shader. It uses them from separate shaders. So this is kind of like the simplest possible. I suppose you might be able to get just a color node and stick it straight in here, but it might not work in Decentraland. Decentraland is really happy with the BSDF, principal BSDF shader. So this is kind of the simplest alt-click drag, the simplest kind of shader nodes graph, which you once again see by going onto the shading workspace. And then you have these two panes. Roughness. Maybe, I wonder if you can see that if you get close enough here. Yeah, not with this lighting. Can you maybe see it here? It's kind of subtle, but in conjunction with, yeah, there you go. With metalness, metallic, you can get really mirrored effects. So if you turn metallic all the way up and roughness all the way down, you get, it's pretty much a perfect mirror. To explain something that might be a little confusing, what's reflected off of the surface of metallic up, roughness down, is a world map. In Blender, it's this image here. In Decentraland, it's an image of, I think, part of Buenos Aires. And so this image here does not carry through out to the GLB. It doesn't appear in the world. What appears in the world is a world map that Decentraland has as a default. They may eventually allow you to specify that somehow, but right now it's a default. I wonder if there's anything else we want to look at right here. One of the things I want you to see is that the, put a little bit of roughness back on it. All right, kind of like that. There's an emissive emission here. It says how much do you want to emit light from this object, and what color do you want it to be when it's glowing. However, although this works in Blender, this does not work, has no effect in Decentraland. So it's not how you want to do emission when you're working in Decentraland. Instead, to do that, you, I'm just going to put it back to black. Not that it matters, but I'm putting it back to black because it matters in Blender. I'll show you how to add a new node. Here, you add a new node. So we're going to use the emission shader. And it sticks to your mouse, and I usually put it right here. And the combination of emission and the output of these two has to be combined. And the way you combine the emission with principal BSDF shader is different than the way you combine the other thing you have to use a separate shader for, which is transparency. And since I don't have that memorized, I'm going to go back to my diagram here and remind myself of how that is done here. With this is, by the way, this is in the materials of the class today. This is a kind of a complete diagram of, so this has both the transparency shader and the emission shader. And the emission is used as the add shader, and the transparency uses the mix shader. They're all kind of chained together here. So why don't we put them both in and just go ahead and build this little piece and see what it does. So emission and transparency, add a node, shader, transparent BSDF. Just to be consistent with the map, let's switch the order around here. And you know, I can't just say, well, I'll add that in there too, because it disconnects the other one. So that's not the way you do it. You can have one point going to multiple points, but you can only have all these inputs. You can only have it coming from one place. So we're going to get an add shader and a mix shader. So we add a add shader and a mix shader. And again, I'm gonna, I dropped it on the, did you see that? That's fun. I dropped it on the line and it connected itself between them. We want the mix shader to mix the output of transparency and the output of add shader. So the first thing is we're putting the BSDF and emission together in an add shader. So take this guy and put it there. I think it doesn't, in this case, it doesn't matter which one goes where. Emission is going here, okay? So you add emission and you mix transparency. Why, I don't know, but there's probably a good reason for it. The way that the shaders work in the GPU, I think, is the order in which things happen and how they're done. So transparency is mixed as the first of two, typically the first of two shaders here, and the output of the add shader, which contains the other two, gets mixed into the other node here, something like that. So now as we mess around with transparency and emission, we're going to get the effects that we want. So the strength here says how emissive it is on the emissive shader. It's this one right here, and also the color of the emissive light. So let's have it kind of glow pinker than its redness. And how strong do you want it to glow? Well, maybe just a little bit. Emission makes it look like the thing is emitting light, but it doesn't light up things around it. To do that, you need a light. And in Decentraland right now, they support exactly one light, and that's the sun. I think, as I mentioned in an earlier lesson, if you want to get something sort of approximating Decentraland lighting, you want to change your light node. You select it, you come down to the light tab here, and change it from a point light at 1,000 watts to a sun, and not 1,000 suns, thank you, just one sun. And that will give you a lighting that is somewhat like Decentraland's lighting. It's probably your best choice to imitate it. You could add another light or two and get something that's a little closer, because there's some global illumination in Decentraland, I think. So bringing in an area light or something like that might also make it look a little bit more realistic. I mean, more similar. I see a comment here, BSDF directional scattering distribution function. Oh, bidirectional scattering distribution function. People who develop the technology of shaders have all these aspects of what the thing has to do computationally, and I think that describes it in words that I wouldn't be able to explain how they work, but it's wonderful to know what that means. Thank you. All right, so going back to the cube's material, I don't know, maybe you can just kind of select on the cube because it knows that you're talking about the materials on it, but you might have more than one thing in this tree. So just go down to the material. This tab down here gives you additional settings that sometimes are important, but the most important is use nodes. The other what's important is that if you're using transparency, you also have to come over, and this is really important, you have to come over to the settings and change the blend mode from opaque, the default, to alpha blend. And if you don't do that, Decentraland won't see it as transparent. I'm not even sure that yeah, even Blender requires it. It's opaque. It's now partly transparent. The amount of transparency versus the amount of color and emission is controlled by this factor here. So in an add shader, just adds them together, and factor says how much of each. And if you switch it all the way to this side or all the way to that side, you're cutting out the other effect to some extent, but I see some transparency there even so. Interesting. The color of the transparency, see what it does. If it's dark, it's not. Anyway, you get the idea. You're going to mess around with these things to get them the way you want. Oops, that was meaningless. Until you have some light in here. If we make this white for the basic color, then the transparency and emission colors are a little more visible. This is the emission, but I don't want very much emission. You might be able to use a mix shader to control the relationship between the emission and the color, but I think you do that mostly by the strength of the emission. So if I turn the emissiveness all the way off, and Alt-click drag, turn the metallic all the way up, and the roughness all the way down, you get something pretty close to glass. But you want the mix shader to favor the transparency. Anyway, so this is not a complete map, but it's one that involves no textures. So how do you do a texture? Well, typically the first thing you do is you're going to stick it in, instead of using a plain base color, you're going to stick it into the base color node here. So let's get a texture. I'm going to add a texture node, and there's many of them that have kind of predefined textures. Most of them don't work in Decentraland, maybe almost none of them do, but the one you want is the image texture. And now we have an image texture node here. And the color of it is going to go into color here, but let's go get ourselves an image map first. Let's go find something. Oh, actually, I don't want to create an image. I want to open an image. Where am I? Let's see. I keep my library on OneDrive. Here's a brick texture. And it has no effect until I connect that up. And let's go reduce the transparency. When you slide this to the left, you're favoring the top of the two shaders mapped in here. When you slide it to the right, you're favoring the lower one. So the lower one is the one that contains the output from here. I'm going to turn the strength on emission all the way off. And it is still metallic, which I don't want, but I do want some roughness. Okay, so this is kind of an orange brick material, which is not very well mapped to this because I don't have a UV map hooked up. Let's look at what the UV map looks like for this guy. I think maybe the issue here is it might be a normals thing. So in the UV editing, this box is UV mapped using this pattern. And so it's these 6 pieces of the texture map that are being used to paint this thing when you are in layout or modeling mode, and using either this shader or this renderer. I have, I'm a little puzzled as to why some of the faces, I think it must be which direction the normals are facing, and I don't know. I'm not an expert on how to do that. I haven't actually seen this before. Maybe if I get rid of some of these other nodes, that may be part of what's confusing it. Probably not, but possibly. So let's go to shading and simplify this diagram just to take this straight to here. And that seems not to have been what the problem was. Yep, Control Z. I had the wrong one selected when I did the delete. I don't think that this is what is going on here, but let's just see. I think maybe the issue is that we need to have possibly a node called there is a node. Let me go back and look at my map. Mapping. See if I can find the mapping node. And I think that's often fed from a, I don't know if I have it in this diagram. Yes, a UV map node. Add and it's hooked up from the output of the UV to the vector here, and from the output of the vector there to the vector there. I don't think that completely solved our problem, but it's better. And then this, I think that there's some transparency here still. No, it's not that much better. Does somebody know what the thing I need to be doing here? Okay, so I should remap it. And KJ's pointed out the problem can be solved by redoing the mapping. So I think what I want to do is go to UV mapping so you can see the effect of what I'm doing. And under UV, there's a keystroke for this, but I always like, okay, unwrap. That's not quite. U key. Oh, that is the same thing. There's a did that make it better? I don't know that I've actually done the unwrapping. Go back here, UV editing. I'm slightly confused by the fact that I'm not seeing a bunch of choices on the ways to unwrap. Usually there's a list of algorithms, different ones for unwrapping. Do you know where that is, KJ?
Yeah, you just want to hover your mouse over the right segment of the window other than the left one. There you go. And then hit U and it will come up with the options.
Thank you.
Pleasure.
Smart UV project's not bad. Cube projection obviously is the one you want here. And it's saying put that on all, I think that says put that on all surfaces, but let's just see. I still have this one empty space. There's something about this particular space. Is it possible for me to reverse the normals on this and see if that's what the problem is? I wonder if I get inside and look up. Yeah, some of the faces are kind of turned the wrong way or something. KJ, do you know how to, do you know if this might be a normals problem?
Could be, but I'm not sure. I've never looked on my computer at the same time.
This is not the UV map I really wanted. So let's try Smart UV Project. Now it gave me a different UV map with 6 sections in here. It says these are how the different faces would go. You can, if you want, you can move things here and stretch and misshape the thing. But anyway, let's go back to the, there's some controls over here that are like off the side that I'm just going to go back to the layout so I can see the effect. Yeah, you see the distortion I introduced there? Control Z a couple times and it undid that. Select faces, mesh, top left, edit mode. Okay, so let's normals flip. So which ones are giving us troubles here? We're going to go into layout, go into edit mode so I can mess with the specific faces, clicking here. And I'm going to go into solid mode here so I can see. Can I click the face here? Select. Yeah, I have selected that one. Let's just do them one at a time. And then KJ says select faces, mesh, normals. They're here somewhere. Normals, flip. Did that fix it? Nope. Wow. I haven't seen this before. That the default cube has so much trouble. Let me just open a new file. Start to catch. I'm not sure if something I did had that effect, but let us go to shading and put a texture, image texture here, and connect the color to the base color and open yeah, there was something I had done that messed up the way that usually this is what it looks like. It just works. Okay, the default UV map seems to work okay on a cube, but if you have a more complex object, you're going to want to do that unwrapping job, which is sometimes a little complicated, but I'm going to show you kind of the simple version of it by going in here to UV editing and say, hover over here, type U. There's other ways to unwrap something. Smart UV project is often a good choice for a really complicated shape. Another one is if the thing is a cube or kind of started off being one of these things, sometimes you can project it out as that. Another one that I've seen work reasonably well sometimes is light map. But let's add another object in here. I'm going to add the Suzanne monkey object. Actually delete this guy. And we're going to go back to our shading and hook that back up. This thing doesn't have a map yet. So we're going to add a output, material output. Do I already have one? Suzanne doesn't have a material yet. That would help if I had a material. Okay, so under materials here, I add a new material. Now she has material, and guess what? Default, we have the two things we want. And now if I add a oh, that's actually what we need. Go back to UV editing here. There. Now you see what the UV map looks like. This Suzanne came with a UV map. Kind of like, I think these are her eyes. This is her face around the sides. This is the back of her head. And one of the things you can do is you can create an image. Okay. And it starts off black. And I think if you go to I haven't hooked it up. Okay, so I'm going to add a texture, image texture here, and put the color into the color input. And now if I scroll in here and open, oops, pick the, I think this is black Untitled one that I just made. It was black before because there wasn't anything. Now it's black because the image is black. If I go to texture paint, and let's say I want to make her eyes white, except in the middle. So what I could do is I could go into painting mode here, and my brush radius is too big. I want to maybe make it 5 pixels and make its color white. And oh, 5 pixels was a little small. Let's make it 15, 20. This is an approximation, so we're not going to do a perfectly pixel perfect job here, but you can go outside the mesh and it's okay because that doesn't get mapped to anything. But the other thing you can do is you can paint right on here, and you may notice that when I release the mouse, it also paints over here. So you can paint either place. You can paint on the object, which is often really the best way to do it. And this is if you want to paint your own image map, image texture for an object. Let's go back to our document. Scrolling isn't working. Oh, no, it's just very slow. Okay, so I think we've talked through that you do that work on the shading. So once again, these are workspaces up here. This is kind of like just seeing the whole thing. This one's kind of laid out a little bit more for working on modeling. It's a less encumbered view. UV editing is where you work with image files and kind of a grid overlay of a mesh overlay of the UV map as represented. So remember, this point here is actually 2 additional coordinates in a point over here somewhere, but the UV map is stretched out into a 2D space as an overlay for an image. So you can paint on the image. Texture paint is actually where you have the tools for painting. UV editing is typically what you have the tools for doing the layout of the UV map. Shading is where you have the material nodes down here. We'll get to animation later. Talked about using sun for the light, selecting a particular material. By the way, it is possible to have more than one material because your UV map can map different materials to different parts of the mesh. You can actually have multiple UV maps. So when I said you can have 2 more coordinates, well, you can have pairs of additional coordinates for multiple UV maps in your mesh. I think we've gone through this pretty well. Transparency. I see that some of you have been passing around links to the document that I have on transparency. I did update it a couple of weeks ago, so it's pretty current. Thank you, Ember, for the note there. I'll take care of that. So in the documents, you'll find what's a pretty complete map of what you do. If you have a UV map in your model already, typically you don't need to add all that other stuff, but I think that this stuff is useful when you want to modify the way the UV map works or pick a particular UV map when there's more than one, for example. I've never figured out when you do or don't need these additional pieces. Typically, I find that I don't need them. If I have a model has UV map, I can just hook up the image texture straight up, and it just works. So let's talk about the texture files. Decentraland has defined how texture map sizing should work. They should be squares. They should be a power of 2 pixels on each side, like 512 by 512 or 256 by 256. Their documentation says 512 is the maximum. I know several of the developers, including some of the leadership there, thinks 512 really is not adequate, but they're kind of holding the line on that right now, at least in the documentation. I happen to know that they don't lock out 1024 by 1024 currently, and I suspect they never will because they're probably going to officially enable it at some point. But they're trying to encourage people to use as small a texture files as possible because they are expensive to render, and they take up space. If you make something twice as big on the side, it's 4 times as big of a file. So for many things, 512 by 512 is just fine. A lot of my scenes, barks on the tree, leaves and things like that. In many cases, I'm using 512 by 512, and they look pretty photorealistic unless you get right up and put your face right on it. There are some things that I find that, like, for example, in my Etheria district, rental, proof of concept rental tool, I have a map of the world. No, excuse me, a map of the district, and it's, you know, it's a really big district, and you want all the parcels to show as little squares. And to do that and not have it be blurry, I had to have it be 1024 by 1024, and it works. I can tell you that if any dimension on your, and listen carefully, this is a hint for one of the problems in this scene, in the assignment. If any of your dimensions on your texture maps are greater than 1024, that part of the map just isn't used. So you'll see that as part of the clue on how to fix one of the problems in the assignment. You know, the textures themselves have to live in a somewhere in your file structure. There's really two places I put them. If they're part of a GLTF file, an external image on a GLTF file, I'll put them in the same directory as the GLTF. In fact, you have to. So they'll typically be in the models directory structure. If they're intended for a primitive, I usually put them in a materials folder, parallel to the models folder. Just to say that these ones go with primitives. Where can you get texture images? This gentleman has the Polygon site, has super high quality stuff. It's a subscription if you want to get access to his things. The Blender Cloud has a number of textures. Blender Nation has free textures. There's also other free texture sites. And some of the things for sale in CG Trader are textures. And you can go out with a camera and take a picture of concrete or wood or brick or whatever you want. Make your own texture images and give you a unique look. You may have to mess with it to get it to lay on the object the way you want. And there's an issue of tiling. So if you have a very large surface to cover and you only have like 512 or 1024 to work with, you might find that you want to repeat the image across the surface. It's called tiling, and you can do that in Blender when you set up the way that the UV map works. So maybe that's the reason for that other module exactly. Where was that? Up here? Yes. I think that the settings in this allow you to do things like repeat the pattern within that area of the UV map. So when you tile a pattern, unless the texture file as a whole is something like a tile with half the grout around the outside, when you tile, you'll see a repeating pattern in the image, even if you don't mean to have it look tiled. So if you want to have that effect go away and just be a continuous surface, then you have to get texture files that have been intentionally designed to be put side by side and not see a seam. You can buy them or you can make them. Here's an interesting tutorial showing somebody how to take an image of some wood, bark on it's an old wood surface, and it has knots and it has things, and you tile it, you can tell it's tiled, and then right in Blender, he does some clone brush painting to move around some of the texture, some of the image to other parts to make the tiling much less obvious. So, but you know, some of these sources, if you look for seamless textures or tileable textures, then you can get, I want to, Studio Sky. This gentleman is one of the top 3D and 2D artists working in Second Life and Sansar. And he's expanding out to Unity and Hypergrid now. And his work is just phenomenal. And you can, he has models that only work in, that you can only get through the stores of Second Life, but he has textures. Has he gotten rid of them? Oh no. Building kits. Maybe he has retired them from his site. That's too bad. Beautiful stuff. I bought a whole bunch of it and use it. The grass that I use in many scenes, you see, is just one of his. I'm sorry to say, it looks like he doesn't have textures for sale anymore. What a shame. I've tried to get him to come and work in Decentraland. I may succeed someday. I have many of his models in Second Life. Anyway, here's sources, and there's others. You can search for free seamless textures, high quality texture files, things like that. And there's many places you can get them. Okay, let's talk about SDK 5 and SDK 6. There was a major upgrade to the SDK from 5 to 6. And they changed the SDK, the objects, the method calls on them and stuff to some extent. And there's a document that, the migration guide. There's a document that Decentraland wrote about how you migrate an existing 5.0 project to 6. Most of you, if you've started since that happened, haven't had to face this. But if you had scenes from before, they don't show up in SDK 6, not because they're radically wrong, but because it's just a few things that have changed that end up making everything not show up. So the assignment in this lesson starts with an SDK 5 scene that worked. And the first part of it is to get it to work in SDK 6. In other words, get it working again. And then there's a bunch of problems with it. And here's the assignment. So before, let's see, there's a question here from KJ. I don't know the answer to whether 1024 is going to be disallowed before the end of September. My guess is they're never going to disallow it, that they will eventually officially allow it. I'm working on that assumption. I have a lot of 1024 stuff in my scenes, but when I do that, I know in the back of my mind it's possible that they will suddenly lose their textures, and that I'll have to go back to my original models, pull the texture files out, shrink them to 512 by 512, and put them back in. If they are GLTF files, that's easy. You can just replace the image files with a smaller version of it external to the GLTF file. But if they're in the GLB, you're going to have to open it back up, extract the files, mess with them. One way you can do that is re-export it as a GLTF and shrink resize the files, and then reload if you want it to be a GLB, import the GLTF into Blender and re-export it as a GLB again. One ends up often doing stuff like that goes back and forth between the GLTF or GLB files in Blender. So yeah, I have a lot of 1024s around. I think that they will never actually prohibit them. The documentation says they're prohibited, but I think there's enough people within Decentraland that know that 512 is not always enough, that they probably will never actually lock it out, because they may break some of their own stuff even. So that's my thinking about it. Sometimes when I'm building the images, I'll go ahead and build both sizes of them at the same time, so I can more quickly swap them in if I need to in the future. Or I can try them out in 512 and say, you know what, actually that is good enough, but I have a 1024 for later if I want it. So that's one way to approach that. I hope that answers your question. If in doubt, use 512. It often is good enough. All right, so there's a scene that was made in SDK5. It's actually one I had around. I went back and reloaded SDK5, which you can do, and put a few more things into it for this lesson, and introduced some problems on purpose. Anyway, so then I went through and I did the assignment myself, and at the very end down here, there's a link to where the working, an example of what a completed scene looks like. I'll just open it up here for a second. If I do this, can you hear this sound? Oops, it's not there. But do you hear bird sounds? Crickets? Anyone? Yes, cool. I didn't know whether my computer sound would be reflected, but you know, I have a bird that flies around and he chirps when he flies. I have some crickets in the bushes here and there. I have some other ambient bird sounds up here in this tree. I have a pair of cubes side by side. One is a primitive cube, one is a Blender cube. If you click on the brick cube, it forces the bird to fly, but the bird flies every 10 seconds anyway. So this is, your scene doesn't have to look exactly like this, but this would be an example of assignment 6 plus some of the bonus materials, some of the bonus assignments. And this is if you click on the bird, it flies. And clearly animations aren't entirely broken. Anyway, happy with this scene. I finished it last night. Let's go back to the lesson. I think that I will start through the process of doing this lesson, so you'll see what you have to do. It's a little challenging in areas, and we probably won't get through it, but I'm okay with going past 1 o'clock. So if you are too, then we might do that. So you start by going and getting rid of the cricket sounds. By the way, I think I've mentioned this elsewhere, but when you're putting sound in a scene, I think you don't want something that's going to drive people crazy if it just loops and loops and loops and goes forever. You want some variation. So one of the things in that scene is that the volumes are turned way down. The sounds are placed in different places so that as you walk around, you hear some things more than others. Typically, the volumes on the sounds in there, except for the chirping bird, are like 0.1 or so. They're pretty soft. That depends a little on how loud the sound itself is, but when you get sounds, you can bring, the tool I often use for messing with sounds is Audacity. This tool right here. And if you get a sound, like this one, oh, okay, I moved it. If you get a sound like, let's just see if I can exemplify this. Yes. This is from freesound.com, which is linked in the lesson plan today. They have birds and animals and crickets and all kinds of stuff. If I play this, however, this sound doesn't occupy all the volume that it could. And there's one thing you can do is you can, under Tools, I think it is, and no, Effect. Under Effect, Normalize. That says increase the volume until the very loudest sound does not hit the top or bottom. Oh, I have to select the whole thing first. Select all. Effect, Normalize. These are good settings by default. And the result is that it fills it vertically as much as it can without clipping anything. I think there's probably, even though you don't see it at that zoom level, there's probably a, where's the slider? Excuse me. There's probably some waveform here that does get all the way to the top or bottom. But anyway, typically you want to normalize your sounds so that then when you're working with them in the world, you can attenuate them, you make them softer, but you can't make them as much louder as you might want. You can always turn them down. But I don't know if you can set a volume greater than 1. Perhaps I'm wrong. But it gives you a kind of a standard sense of, I want the sound to be full and nice and loud, so I'm just going to put a 1 on it, and I want it to be soft, I'll put a 0.1 on it. But if some of the sounds that you're using are already really soft, then that intuition of what that setting ought to be, you'll have to just mess with it more. So normalizing the sounds is good. Audacity is free. It's my recommended audio editing tool for you in Windows. Having put away the finished lesson, let's go to the let's go get ourselves a copy of this lesson 9 Fix Me project. I'm going to get the HTTPS URL. I'm going to open up So we're now doing what you're going to do this assignment. You're going to get, first of all, get a copy of that scene. And I think I'm going to actually rename it. Okay. Package.json says which version of the SDK it should be made with, and oops, can't make it with 5 anymore. I'm going to edit the package.json file and change this to latest, which means it'll get the latest 6 point something when I build it. Control S. And it does not have the, like most of our scenes that we put up into Git, it doesn't have the node modules, it doesn't have the SDK installed locally, the ECS. So I'm going to do that. No. That should do the job because this package.json specifies that dependency. And now if we do a DCL start, I think we'll see nothing. Just a, It looks like it's one parcel with nothing in it. And so let's see if we can figure out why. Just going back and following the instructions here. When you have the SDK installed within a scene using npmi, then Visual Studio Code will know about the SDK classes and methods and will give you a syntax highlighting error if something doesn't look right to it. So I'm going to actually going to kill the preview. My memory seems to be a little bit busy today. So code, oh, come on, code source game code source game. I see a syntax error here. Looks like just one. One of the things that changed was the add component method was substituted for the set component. It was basically they finished going to a real entity component system syntax in their script. So instead of using sets in lots of places, they changed it appropriately to add component. The syntax error display shows that it doesn't know what a set is because in SDK 6, an entity doesn't have a set method. There is this document that I had open earlier, migration guide, and it says, here are the things generally that you need to do to change the old code to the new code. And the main ones we have to deal with is the component stuff. So we're going to change this to add component. And now the syntax error goes away. However, I think the scene still won't work. Let's go back here and do a DCL start and see what we get. I think we might see an error message. Nope. I'm hitting F12 to see if we get any kind of clues here. Entity.set is not a function. So I'm still getting that error. Anybody have a thought about why? Even though I fixed that? This isn't all of my code. I have an import. So if I right click here, I can actually go to the definition, which will open me up in the spawner functions file. And guess what? I have a bunch of them in here too. Every place that it happens, the word entity appears before it. So I'm just going to do Control C, select the whole file, edit, replace, and turn on, do it everywhere that I have a selection, and change entity.set to entity.add component. Click on replace all, and no more syntax errors. Code is so much fun. It shows you all the places you've made changes since you I think since you checked in the file last. I think it's actually smart about Git, but it's certainly since you opened it last. Anyway, so now it might just work. Let's restart it. Did I save that? Nope. Okay, now I did. Oh, how did I open that file? Oh, I see. Yes, the way you do it is if you have an imported thing from someplace else, or in general, you just want to see where something's defined, like in the SDK, you can actually go look at the declaration of this in the SDK. But in this case, it's some of my own stuff in a module. I right-click on it, go to definition. Probably I can use F12 too. Yeah. You'll actually go find the file and open it, take you to the place where that is in the file. Question, does it help to use a scratchpad file in Visual Code to copy paste? I use Notepad sometimes when I just want to put something somewhere for a little while and then bring it back in. But you could create a new file to do that. But another thing I do sometimes is, let's say I have some the output from the Builder HUD is a really good example. I'll have some gobbledygook that is not, it's just coordinates, or maybe I have the name of the path and file name of something that I want to use. I have it in my clipboard, but I don't have all the syntax in which to drop it. So sometimes I'll just put some stuff here, and yeah, it's a syntax error, but that's fine. I'm going to fix it. In fact, if I need to keep it around, I can comment it out temporarily, and then I can copy things from it into where I might want to put them. So I hope that answers, Jacob, your question. I often just use, some space in the file I'm working on as a scratchpad to hold some stuff. It's interesting to follow up a little bit more on the question about, I have noticed that sometimes there's other methods in here besides the ones I have. And if I've already imported it, notice that it knows methods from that import that I haven't used yet. It shows the 3 at the top that are listed explicitly as part of the import. But let's say I want to do a cone. So I actually can do this. If I hover here, I think that actually I probably have to do that. I think that quick fix, add spawn code to existing import declaration from module spawner functions. If I click this, it's going to add the cone up there. Pretty smart. So you don't have to remember what that other thing is or go type it in up here first or go look for it. If you kind of remember that it's probably something let x equal spawn. It goes and looks and sees all the other things that are exported from there and gives them to its options. They're just marked a little differently. Cone is now up here in this list. Isn't that cool? Anyway, I just find code to be a really nice integrated development environment. Does your game TS file know the global commands for SDK and Decentraland? It sure does. So for example, if I say let x equals new, and it won't, I mean, that's a vast list. It doesn't do it for everything, but it knows them in the sense like, let's say I want a new transform. Now, I don't have transform in here anywhere yet in the code, and yet it knows that TR could be, maybe I misspelled transform, I meant texture. Let's just do this. And then it also knows that the only argument, the only parameter is an optional one for the constructor args. Because as you remember, you can do this thing where you like position. You notice that it knows that one of the things that can go in there is position. So yes, it's very smart about that. It can really help you. I think you hit a tab and it fills it out. Colon, new vector. Thank you. It even knew that vector 3 was one maybe I'd use the most often. Of now it's going to if I put any parameters in it, I guess you can create a vector 3 with without any parameters, and it'll give you all zeros, I guess. But if you start putting parameters in, it's not going to say, oops, I'm sorry, 3. Even before that, oh, I see all of the parameters are optional. You see the question marks up there on those? That means when the thing was defined, it was defined in a way that the parameter does not have to be provided. Any parameters beyond the ones you do provide are defaulted. I'm going to go to the definition. And we're opening up the interface file between JavaScript and TypeScript. That is how you use the JavaScript library in TypeScript. This is the interface file for the SDK. It's a really big file. You can see over here, it's huge. But the vector 3 constructor has question marks on the variables in the function in the constructor definition, which means that you don't have to supply them, and they'll be treated as zeros or a default value. So yes, the code knows a bunch of stuff about the environment, the development environment libraries that you're working with. All right, so let's go back to the scene, and oh, what a mess. This is a new feature in the latest version of the SDK, in which objects that stick outside of your scene are flagged with orange mesh. They kind of put an orange shroud around it, and then they also put little boxes around the pieces that stick out. So I think the first thing I'm seeing is that the trees in the scene are out of bounds, right? So let's start cleaning some of this up. There's a box here that's too far south. There's a box inside that's okay. This bush is out of bounds. There's a row of 3 trees here. Do you remember in the original picture of the scene, the top of here, there's a row of 3 trees and 2 grassy tufts. It's because there's a GLB file or a GLTF file that's being used here that has 3 trees in a row, and it's too big to fit in a parcel. So one of the things we have to do is go to town on that Blender file and reduce it to 2 GLBs, one for a tuft of grass and one for one tree. Also, this tree here in the front is I'm trying to zoom in. Sorry, can't walk in the scene. It's too large and placed in such a way that almost all, a great deal of it's outside the scene, so it's breaking the rules. So maybe we try fixing that one first, but there's so much junk in the other one, I don't know. It might be hard to see if we're getting it. So let's start by reducing that tree. I think that tree is called a fir tree here. And even though it's only 0.3, let's make it 0.1, 0.1, and 0.1. And it's right now it's at just 2 meters in from the southwest corner of the scene. Let's just put it in like 6 to the left and 11 back, something like that, and see if that makes that tree appear and not be out of bounds still. No, it's still not happy. Still, still too big in some way. Let's just make it really small for now. Let's see if it shows up. Yeah, there it is. There's a bug in the current SDK. They have a fix they're going to be releasing soon. But even though you got it in bounds, and it may have been on the previous one too, it still is orange until you do a hot reload. So I'm going to do a hot reload. I mean, explicit reload. It did a hot reload, and that doesn't get rid of the orange shroud on the thing. There, we have a tiny tree. Let's go to work on this other thing. I have something in here called Nature Pack. And let's go look at that thing and see what it is. So killing my scene. The GLTF file with a bin file and a bunch of images. Curious how big these images are. I'm opening up the Explorer on this directory. Right click, properties, details. It's not square, it's 512 by 1024. Breaks the rules a little. I'm going to use the Babylon sandbox and drop all of this content and select it all to not only the GLTF, but also the mesh bin file and all the images, and click and drag those onto this surface. And indeed, I see there's 3 trees and 2 tufts of grass. And that's too big for the scene. I really want a tree model and a grass model, and I can put them where I want. If I want to have more than one, fine, but I don't want the Blender file to necessarily enforce that they're equally spaced like that. So I'm going to open up Blender and cut this thing up, this GLT file up into a couple of other files. Start by deleting the default box and file, import a GLTF file, and go back here to this directory where this is. I'm working right in my scene directory on the models. Opening it, and I can see, yep, indeed, 3 trees, 2 bushes. I'm going to shift select both of those, and does the delete key do the job? It sure does. Nice. Let me get rid of one of the bushes too. They're the same. Tufts of grass. All right, so now I'm going to make myself 2 Blender files. Yeah, maybe I'll show you a different way of doing it. So I've selected the tree, file, export, GLTF. I'm going to leave it as a GLTF so that I can mess with the textures if I need to externally. But I always click apply modifiers, but I'm also going to pick selected objects. And notice that the tree was already at 0, 0 on the ground, and where it was located is the center of the origin of the space. So that's good. It'll come out centered. When I place it somewhere, it'll be right there. Instead of being offset like that grass tuft would be. So I'm going to save it and, you know, just to keep things a little bit straight, I'm going to make a subdirectory in here called new folder. Actually, I'm not going to make it here. I'm going to make it up here, I think. Make a folder here called tree. And I will go in there and I'll get this folder name, this path, put that up here. And I'm going to call this thing tree. Double checking that I have it GLTF with separate textures. I'm doing the selected object, so I should only get it. Let's just go see if we succeeded. We have a tree, we have stuff. Let me drop that into the Babylon sandbox. Nice, a tree. All right, so let's do the same thing for the grass tuft. So I'm going to, you know, I could save this Blender file, or I could make two different Blender files. I'm going to kind of shortcut that. I would normally do that, but I'm just going to delete the tree. And then I'm going to right there. That select object, I'm going to move its geometry to the origin. The origin is marked with that circle at the beginning. It's also something you can place in the scene in case you want to go put something somewhere else, but I'm going to do that. And it didn't work, and it sometimes doesn't. So instead, what I'm going to do is take the move tool. Sometimes I'll move it just right. It seems like it's only off on that one axis, so I'm going to put it right there and rotate around and make sure it looks like it's pretty well centered. Oh, it's a little low. I don't want it to be below the ground. I want it to be on the ground. Okay, it looks pretty good. Maybe I'll move it down a little bit so the roots are slightly embedded in the ground. All right. Actually, I thought maybe more than I want. How much? Looks pretty good. Okay, so now I go File, Export, GLTF. Selected object's fine. It's optional now because obviously I only have the one object. So I would typically not do that. I have to create. You can create presets for different patterns of how you want to export, and I have made two. One called Decentraland GLB, and another called Decentraland Unembedded with mods. And in both cases, I have modifiers checked and that unchecked. So, for example, if I pick that, I'm going to get a GLTF here instead of GLB. Anyway, you can create those presets here. Just to check and make sure it works well. Yep. I'm being sloppy in that like I said, I probably would normally put all these things in the right directories outside of the scene. I would make a blend file for each one of them, etc. But I'm shortcutting that just for today. So this is an example maybe where I would use Notepad maybe to get the names of things somewhere where I can use them. Remember that Windows likes backslashes, but the rest of the world uses forward slashes. So there is the path for my Stick it here for now to answer a question. It's using the code itself as the scratch pad. Let's do the same thing for getting where the tree is. I'm lazy. I know you could type all this, but I make mistakes when I type. So I use copy and paste a lot. Okay, so the nature pack goes away and becomes instead a tree and a grassy tuft. So I'm going to copy this line, paste it again, put these two guys up in here instead of what was there. And I'm going to call one of them a tree, one a grassy tuft. Let's get the right one. No syntax errors in here. However, the two things are in the same place exactly, and that may not be what I want. Let me just move the grassy tuft meters closer to the front. And now if I control F5, oh, I probably stopped the scene. Did I? I did. Well, I see a tuft of grass, and I see a tree that is awfully big and still sticking out of the scene. There's southwest, there's west, there's northwest, there's north, and this is the southwest corner of the scene here, just for reference. Both the cube and the that new tree are out of the scene. The tree is just way too big for one. So let's scale it at maybe a third that. And then there's a cube. It's the one that's closest to the front, right? So let's just push that back a little bit. Control F5. Oh, it's still a little bit, looks like the hot reload actually worked partly that time. This box is still a little out of place here. And so let's move it back a little further. Ah, they may have released that bug fix since yesterday. The hot reload seems to be working better now. Yeah, it took that long before the scene responded to my mouse. All right, here's another problem. The scene in SDK 5 was 10 meter by 10 meter. So we're going to have a 6 meter gap out here on the east and on the north. So let's make the ground bigger. There it is right there. We're using a plane and tipping it over 90 degrees because a plane, when it first spawned, is vertical. It gave me 3 on every side, so it actually hangs off the front and the left now. So I actually need to move it to the center, which is now not 5, but 8. Yeah, it's starting to look a little bit better. What's the next thing in the assignment? So the next thing I'm asking you to do is make the ground cover better. And that's, you know, it's defined here as a green. And RGB. G is the larger of the three, so it's mostly green, but has a little bit of red in it, making it slightly brownish instead of just real bright green. But it just doesn't look great. It's not a great ground cover. So one thing you could do is you could change it to use a texture material that has grass. You could use the one from the builder. You could use go out and take a picture of grass. Probably won't get a great result, but it would be fun. I think the grass would look really big unless you took a picture straight down 16 meters of grass. But you can do that. Get a sky hook and just, you know, hang upside down and take a picture with a high-res camera. Short of that, you could also, my instructions suggest the possibility of using my I have a ground cover code module. Didn't I put that here? Or use the ground cover module from the scene, yes. So let's do that. You'll learn how to do it that way. I already have that existing on my machine, so I'm just going to go find it, find the two scenes that we're working on. They're both now on my D drive. And actually, let's go to scene base first. So in the library, and scene base has it. Using beyond compare to compare the two modules and move things around. Class 9B. Oh, I actually want to go up and do it from here. Right click, compare to scene base. Titleable textures gives me this texture that I want. It's a 512. Copy to right. It will build a folder structure necessary as well. Give you a materials folder. We might end up using the builder HUD in here, so let's copy it to the right also. It might be useful. Models. I need both of these for the builder HUD. And for source, among the modules, I'm going to add builder HUD and ground cover. We are officially at time here, 2 minutes left. How nodes is there? Excuse me, I do have a question. Is there any example of how nodes in a GLB file translate to how it looks in code? Say you copy pasted 10 of the same line in VCode. Is there an easy way to select all of a definition instead of changing them all? Name, number them differently. I think you're asking if I wanted to have 3 trees, or, for example, this tree here, Control C, Control V. What do I have to do to have it number these, for example, like 1, 2, 3? And is there some automation for that? And I don't think so. If you're doing a whole lot of things, you might consider using a code array to do them instead of having everyone be explicit. So you could have an array of trees. It's still, you're going to have to do something to make each one of them uniquely positioned. But if they're part of some sort of animation system, you remember the rotating pink balls in the sandbox next to the pavilion. Those were all generated programmatically. And so he didn't have to go in and make separate lines like this for each one. He actually used code to generate those. So that's one way of doing it. But just to do what I just did, no, it's pretty much a manual job. Control C. There. So anyway, we're at time. I'm going to go continue through the lesson. There might be another hour. Somebody else is wanting to use the space, the Zoom space a little later, so I'm going to try to keep it to not more than another hour. But I'd like to go further through some of the work on the scene, so you're welcome to stay, and we'll continue. The next thing in the assignment said to, you know what, it used to be that planes looked kind of foggy, but I'm not seeing that so much here. But let's put a texture on this. No, let's use my ground cover module. That's what we're going to do. So in here, we're going to, oh, I'm lazy. Let's open up the scene base file, source file, this one right here. Open with associated application, I bring it into code. And here's the import line for the ground cover. We're not getting a lot of advantage from ground cover, the module, by what we're going to do here. We're simply going to put a texture on the ground. But it has some other features, like if you want to put paths within a parcel, it knows how to do that, like with two different materials. So if you want to take a look at it sometime, you're welcome to use it. And so instead of all this stuff here, we're going to use let ground equals new ground cover. And ground cover is the ground cover module is based on assumption, it's placing it at the southwest corner of it, not in the center of it. So we don't have to put it offset to the center. But the parameter list is looking for is the if you want to move it around in the scene, but I'm going to put it at 0, 0. And it also likes to know the width and the height and the depth. So regular XYZ format. So 16, I'm making it thin, just a centimeter thick, and 16. And then it looks for a material. So we have a material, but it's not the one we're ultimately going to want to stick with, but I'm going to call it ground material. And not like it because it's not defined yet, but we'll fix that. Do I want to add it to the engine automatically? Yes, I do. Thank you. I think that's it. And if I move this down below, what's the difference between let and const? Const says, I'm not going to be making further changes to that variable. It's going to stick with, I'm not going to be editing it further. Let says I can. So they're almost equivalent. I don't need this anymore. I do need the material. I don't need that anymore. And I think that that will give me the same look I had before, except that, yes, it does look different because the texture on a plane has kind of a foggy look to it, like somebody sprayed something translucent on the surface. It's just an issue in the SDK that planes look kind of foggy. And this is a very thin box instead, and it looks better. But I think I want to use my grass material. So I'm going to go back to my scene here and go to my materials, titleable textures, get this part here. And the name of this thing, Control A, Control C, slash that, turn that slash forward. Ground material dot albedo texture equals new texture of this. You see how I use the code itself as a scratch pad temporarily. And I no longer need the color part. I don't think so. I don't think I need that. I'm kind of commented out, and I'll go back and look what this looks like. And it should have, yeah, grassy texture on it. It looks better. Looks slightly more realistic. This texture is not tiled. It's stretched over the whole surface. So it looks kind of blurry. The Decentraland SDK has a bug in the UV mapping for tiling right now. It doesn't work, or at least not last time I tried. So I would otherwise tile this, probably use 16 by 16 of them, and then I'd have something really look like grass. Going back to the assignment, I'm going to save my work here, and I did already. Make the primitive box a dark green color and very reflective. Make the ground cover to have a texture image. We did that by using the ground cover module. The primitive box needs to have a material. So let's give it a material. So here is the spawn box. Let's see. Box material, oops, I need a const. Box material equals new material. Box material dot albedo color equals color 3 dot green. Now, I don't think we're going to leave it this way because that's not a dark green, but let's just see what this looks like. And then I have to go, I have to add this material to the box. So box dot add component of box material. Not a dark green. So instead, we're going to go, just a little bit of language TypeScript instruction. So this is a class in the SDK called color3. Instead of instantiating a new one, I'm calling a class method on it. I can call this method without having to have an instance of color3. And the method green returns a new color3 that has the right settings in it. So the equivalent here would be to go, oops. Does it just take parameters? 0, 0, 0 would be black. It doesn't like that. So I think it likes a vector. Oh, no. it likes the word new in front of it. Now I'm making an instance of that class. Class methods are a little confusing if you haven't seen them before. Why is it that you have to use new in front of color 3 except when you're calling a color name on it? It's because there are some methods in that class that can be called on the class without an instance, and they may create a new instance. So this would be black. That would be the bright green again. If I put one here, red plus green is yellow, right? So I'll have a yellow box. But I want a dark green box. So I don't think I want any red in it, but I just want much less green. So 0.3 maybe. Yeah, maybe even a little darker. That's pretty good dark green. And then I want, that's not the whole list. I want metallic. So roughness, yes, roughness equals 0. This would be very shiny. Yep, there's your shiny green box, reflecting a little bit of South America. Not reflecting the grass or the other box. It's not really a reflection. It's not a mirror. It's just a mirrored surface that looks like it's mirrored because it's reflecting something. And the something is a world map, like a 360-degree sphere around this thing of image. Okay, so the next thing in the assignment is put a brick material with base color and normal texture maps on the GLB mesh cube. So I guess we could go get this cube and open it up in Blender and see what's going on. It's sitting at kind of a funny angle. One of the things that the class calls for is, align the boxes to be touching side by side. We saw that in my example of the completed scene, making them the same size and height. This box is a GLB file that happens not to be positioned and rotated and sized right within the Blender file. We could be lazy and just create a new cube that's correct, but let's go the other way and let's open this thing up, because maybe you have something here that had details or something else and you want to take a look at how it is. So we're going to go into models, and there is that's a 9 cube. Let's open up Blender and open that thing up and see what we got. Importing the GLB file, and it's here. Aha, indeed, it's off center. It would be very hard to align these two with the SDK. You could do it with the Builder HUD. That would be one thing you could do, size it and move it with the Builder HUD. But why don't we make it easy for ourselves and do it in here? So I'm going to actually take this thing and I'm going to look at the object parameters here. And why don't I just straighten it out? Make those 0. Don't rotate it. It's pretty square. again, in a way that's silly because this is exactly what it was I just deleted when I started the scene. But I'm using this as an example of you may not be using a cube, you may be using some sort of model. So it's really easier if your model is at the origin when you're working with it. Also, this is a 2-meter cube, whereas the primitive cube is a 1-meter cube. So let's make this half as big. Now it's a 1-meter cube, but it's half embedded in the ground, right? Its origin is the center of the cube, not the bottom of the face. So we're going to actually move it up. And in Blender, Z is up. X and Y are the coordinates on the ground, the red and green coordinates on the ground. Blue, Z is up, RGB, right? So it's X, Y, Z with Z up, which is why when you export the GLB, you say plus Y up. You're saying take the upness of the model and apply it to the Y axis in the positive direction. But we're going to move this up 0.5 meter. And it is now sitting on the ground. It's more what we wanted. All right, but what else are we supposed to do with it? Is there some like texturing to put on it or something in the lesson? Brick material. All right, so I need to find a brick material that has a normal map. Remember, the normal will give it the appearance of some texture, some roughness, some three-dimensional surface. So I have a I had opened it up earlier today, I thought, to get ready for this. Brick concrete walls. Yes, this first one here has, I bought this off CG Trader for a few dollars. It has an albedo, which is the color. It has a normal. So I'm going to grab both of these. Those other maps could theoretically be useful, but I've not found them to work very well from Blender over into DCL and having any effect, but these two do. Normal is kind of a subtle effect usually, but it is an effect. So I'm going to copy those and come back to my scene here where I have I'm just thinking about what I'm doing a Blender file versus I'm just going to put them in here temporarily as a place to put them. Okay, so I'm going to go back to Blender and look at the node on this thing. Blender likes putting lots of spaces in here. It's kind of, I don't know why. So I'm alt-click drag. Question from Ember. My albedo color is not functioning at all, brick texture. Maybe in a moment we'll see how that needs to be set up. And then we don't have any easy access to a normal map. It's all right for us to forgo that. There are methodologies to turn a color map into a normal map. It usually doesn't produce a great one, but it does produce one. And I'm sure you can find tutorials all over the web for how to do that. And I'll leave that as homework. I'd like you to try to either find one that has a normal map so you can see so you can practice hooking that up. It wouldn't be the end of the world if you can't figure that out, but that would be my preference, is to not forgo it. We're going to add a node that is a texture, image texture. And we're going to add another one for the normal map. And then the color will be attached to the color, and the color here will be attached to the normal, which I'm looking for. There it is right there. Okay, and now we're going to open those two files. And by the way, when you're working with Blender, typically you want to embed the images into the Blender file. And the way you do that is on the File menu, External Data, automatically pack into Blend. I'm not sure why it seems to work even without this being here, but maybe it's because when you export the GLB, it sends it along. But anyway, I like going ahead and putting them in there. And so that way it's all in one file. And now we're going to open up, where do we put those? Over here. The albedo. There's got to be a good reason why albedo is called albedo. Does it have something to do with painting, ancient painting with egg white or egg yolk or something? I don't know. There's some history there that I do not know. And then same here with the normal map. I lost my clipboard. Let's try that again here. This. And the normal. It's not a real strong normal map. Let's see what it looks like. Should be kind of a purplish color. The I don't know exactly how this works, but oops. Oh, interesting. I somehow got the other one open. Oh, it's going through this directory at the arrows here. So I see. I wanted to zoom in, but there it is. This pale purple color means that the surface is flat and light should reflect off it like it would off of a mirror. Not necessarily shiny, it may be diffuse, but like a flat surface. And the other colors are used to tip the reflective direction to represent the edge of something like a brick. And that's how it works. And there are tools out there for converting a image file to a texture, to a normal file. Convert color to normal. They don't do a great job, but maybe this one. I've done this once before, but I don't remember where I did it. Shader map for Windows, buy now. I thought it was free. Oh, here's something about why they're colored the way they are. Oh. Here's an 8-minute tutorial. Here's another tutorial from Blender Guru. These were, just, okay, convert color to normal map in Blender or something like that. So you can create them from the color map to some extent. They're not great ones necessarily, but they will provide some texture to the surface. So going back to Blender, we have the right texture on it with the normal. We have it positioned nicely in the space. And there we go. Especially look straight on, you can see that it actually looks like there's texture here, right? Like it's the grout is, the mortar is that effect goes away when you look straight down the side. It really is not distorted geometry. But when you look at it for most viewing angles, it looks like there's a little bit of a texture to it. So it's a technique you want to know about. I'm going to export this back to the GLB file. I'm going to be so bold as to write right over the top of the other one. Again, not necessarily what you would do in real life, but this is virtual life, right? So double click. Now, I really ought to at least save the Blender file, right? In case I want to do something a little different. So I'm going to do that after it finishes this export. The red here means that it's warning you that the name you're using is going to be the overwrite. Overwrite something that's already there. I'm wondering if the reason Ember is not seeing it is because he's on, or she's on the solid view instead of one of these others. That makes a big difference. You don't get the red material renderedness here on one of these two. Can you confirm that that's the solution? Great, that fixed it. I am going to save this Blender file, and I am actually going to save it in the same place, naughty naughty. But it's not that naughty, because I have a DCL ignore file, which I'm going to open with associated app, which would probably be code. And this is a longer list of things not to deploy with the scene than the list that comes with the DCL init command. I've added, I think, that many more things to it, including any Blender file anywhere in the scene structure. So if I have any of these things, I don't want them to be treated as the deployed scene either. They're just part of my development work. So by putting that here, copy to right, while I'm at it, when I put the better git ignore over there too. Oops. Yes. And copy to right. It has a few things that I don't want to push up into Git, like the bin directory and the node modules, but a few other things that were beyond the one that comes with DCL init. All right, so let's also copy the now JSON over there, even though it has, I'm coming from my scene base, kind of reference a scene. While we're remembering that we have this, let's open it and change from scene base in here to lesson 9B. Okay. Going back to, I've copied that in there. Let's reload the scene. See what we got. probably hot loaded it, but I guess that my habits don't fully trust that yet because it's a recent improvement. Yes, except for one thing. They're not side by side. It looks like the brick one is about half a meter high. So let's go look in the code and see what's going on with that. The cube is set at 1 meter. The box is set at 1 meter. Oh, the primitive box also is halfway in the ground if you, so I'm going to go 0.5 here and make this 0. It's on the ground properly. There they are, side by side, same size. All right, going back to the lesson. I'm going to acknowledge that learning Blender and learning TypeScript, if you don't already know them, they're pretty sizable learning curves. I do really recommend that you go to, if you want to learn more about either of them, you go to their sources, go to blender.org and look at their tutorials, or some of the tutorials I've listed in my Blender notes. TypeScript, you just go to the TypeScript site and there's reference stuff there you can learn. I have to go back there sometimes to learn how to use complex for loops and iterators and things like that. Sometimes I don't remember the syntax, but also, you know, those things can teach you not only how to do something that's right before you to do, but also teach you things you didn't even know existed. So there we go. So many things here that, there it is. We've already cut the grass and we solved the out of bounds. So these things were things we did early on. Add a collider to the tree that doesn't have one and to both of the cubes. All right, so in the scene, you can walk right through this cube. Looks like the default cubes now have colliders on by default. I don't know if that was always true. So walk right through this tree. So let's put colliders on them. How about this tree over here? I think it maybe already has a collider. It's kind of small. Yeah, it's bumping me away. Okay. So let's make this tree a little bit bigger and push it back. And we're going to have to do something here about these textures that are messed up. And on this one. But let's start with a collider on here. So we had the GLB file. We didn't keep a Blender of it. So let's go back again to the GLB file of the tree. And we will keep a Blender file maybe. Oh. I hadn't finished saving the brick box. Oh, we need to put a collider on it. Let's start with that. So we know how to make a collider, right? So we create a new cube. Add mesh cube. Do do the same thing with its parameters. 0.5, 0.5, 0.5. And up 1/2. They don't perfectly align. Why is that? Not that it really matters. We must have the other one not quite at 0. I don't know quite how that, we must have just bumped it a little bit. Okay, and then we have to rename this node right here in this hierarchy to be something underscore collider. And I'm going to demonstrate to you that it doesn't have to be cube underscore collider. It can be something, anything underscore collider. So let's call it X underscore collider. Remember, you can make colliders without having an object there. You could have an invisible barrier, for example. So if I hide that, I see the, and they're kind of so close and superimposed in space that you see kind of a hashy pattern on the surface there. Interesting. Okay, so that now we have a oh, we did save it. So I just can Control S and then File, Export, GLTF. I am writing over the other original one. And the only effect that should have when the scene reloads, will it reload automatically from changing the GLB? It did. Presumably, therefore, we also have a collider in here now. Nope. Control F5. I think that there's some things about external mesh objects that don't, and maybe they don't really get reloaded in a hot reload. Or maybe I didn't get the collider on here right, but let's see. Yeah, it's there. So you saw that I had to do a explicit reload to get the changed GLB to take effect. All right, so collider on this tree. Yeah, not that tree, this tree. Okay, so let's open this guy back up in Blender. File, import GLB, put the path here, tab, put the path here, tab, click then, okay. Tree GLTF, and we're going to put a, now you might think that to put a cylinder here would be a good thing. However, cylinders are very expensive in triangles because they're a rounded thing. So we're just going to put a box in. Let's do it so we can see the materials. Okay. File. Nope. Add mesh cube. All right. Now we're going to resize that cube to just basically surround the trunk, at least part way up into the tree. So I'm going to, we have selected it and we're in object mode. I think we can do this in object mode. Scale. So I want it to be in 2 dimensions here, which are these 2 dimensions, green and red. I want to shrink it. There's a little thing floating in between that says do it in both dimensions at the same time. which is kind of nice. Something like that. And then I'll make it taller and also move it up. Now we have a collider. Let's name it. You can always hide it if you don't want to see it when you're editing. You can hide the tree itself and see the thing. And then there's another problem here with, let's jump ahead because the transparencies on the tree foliage that work correctly in Blender 279 SDK5 with Babel and JS rendering are no longer working. Fix their problems. Well, each of the trees has a problem, as you can see in the scene. This one has black where it should have alpha. This one has kind of a little extra rectangles on the ends of all the branches. So let's take this one first, since this is the one that's open here. And this would be a shader problem. So let's take a look at shading here. Use nodes. Tree 1. Zoom out. I have an interesting map here. But there's something wrong with it. So let's see if we can figure out what's wrong with it. I'm just getting it small so we can kind of see it all at once. The shading works okay in Blender, but the way it's being done, oh, by the way, this is one way to make a tree, is to have a collection of planes or thin boxes with alpha map textures on them. Textures that have alphas in them for transparency is what I meant to say. And you get a pretty good looking tree as seen from the side. And it there's obviously a bright light right here in the scene. In this one. Let's just fix that. The light here, we want a sunlight instead. And here's the light. Make it a sun. Make it only one sun, please. There, looks a bit more like what you would expect in the. All right, and it's a pretty good look. Now, how's it done? So it's done by having a texture map that has both color for the painting here, but also has the fourth channel, alpha or A, RGBA, that is set to transparent where the leaves aren't. So how does that work? Let's go to shading. Let's click the tree. Let's go in here and look. So remember I told you that transparency doesn't work unless you use the transparency shader. So I think that's the problem here. So let's put a transparency shader in. We don't need emission, so we don't need that shader. And the transparency shader was combined, looking using the mix shader, right? Is that right? Oops. Well, oh, I see what's going on. Yeah. Yes, mix shader. And my transparency document probably has the right settings too for how you do that, but let's just do it manually and see what we get. Add a mix shader. Here it is, sorry. And these guys get mixed here and sent to the surface. There, like that. Oh, I had them crossed. Let's do it the other way around. Consistent with that. Oh, look at that. Switched them. All right. So, and I'm going to go to my transparency instructions. They are linked from the document as well. I think I have an example down here. Oh, let's go back. Example up here for this would be a good one. And I have for the settings here on the mix shader that the factor is coming from the alpha on the color map. All right. And I do have the transparent on top to make that work. So let's put that back. No, that is right. Transparent on top. The alpha is the factor. So put the transparency on top and take the alpha from here and feed it to the factor. That says, instead of having a fixed transparency setting across the whole surface, I'm going to have the alpha setting, which is the transparency value at various pixels, control the transparency at that pixel. I think that this is going to work. Everything else here is our legal shaders and nodes in for Decentraland. I do not want any metallic. I do want maybe some roughness. It's plenty rough. Okay, so that it's not, the leaves aren't going to be like shiny or mirrored. So let's save this. This file has never been saved, so let's go save it as in the tree. And let's export it. I'm going to use GLTF again. So let me go into this guy here and just save this stuff. Save in a subfolder in case I want to go back for some reason. Back to my scene. Did I kill it? Nope. Control F5. Well, I did something wrong. So what did I do wrong here? I saved it as a GLB. I wanted to save it as a GLTF, and there's a reason why I wanted to do that. Let me do that again then. File, export GLTF. Use the preset for unembedded GLTFs. Click there, but change the name to tree.g. I prefer GLBs for when I'm done and I'm in production, but GLTFs have their usefulness during development. So, and I'll show you what that would be. All right, I'm just leaving this here for now, and the scene should now load because and it loaded from cache, probably Control F5. Do we have transparency? No, there's still something wrong here. So go into Blender and take a closer look. Color, alpha. Oh, I was messing with the wrong material. This says bark. So there are two materials here, and I was messing with the bark instead of the branch, and I gave it some transparency where there was alpha and there wasn't any. So what we need to do is take these two shaders. You know, you can, I think, copy like this. Control C, go into the branch thing and just drop them in up here. And then clean this up. I'm going to delete a whole bunch of stuff here. Control, I'm shift clicking. Delete. Click delete. Click delete. I do want the base color still here, and now the shader is the branch. All right. I suppose I give you lots of room in case you want to add stuff. There's a rationale. Okay, so the mix shader, the transparency was going in the top one. The color was going in this one. The alpha was controlling the factor. I think that's it now. Oh, and we do need to have the output. It goes to the surface. Again, that looks pretty good in here. And our tree, the stuff I added, I'm going to get rid of that on the trunk and just put the color up here. It's brown again. I think I didn't break anything else. All right, so Control S to save it, file, export GLTF. This guy right here. Actually, I probably should delete the GLB because it's wrong. And reload the scene manually. I didn't notice whether the trunk had some transparency, but the trunk material probably didn't have an alpha channel in it anyway, because there was no intent to make it transparent. And still not right. All right, so now what? I have these reversed, right? Didn't we figure out we had to? No? Oh, transparency setting. The thing I've always told you not to forget to do, which is under the branch, under materials, this alpha has to be blend. Control S to save the Blender file, export GLTF. It's faster that time. Control F5. Yay, we got it. Now let's go see what's wrong with this tree over here. Besides being a little too small, I think. Let's fix the size right away before we do other things. It's the fir tree. Maybe 3 times as tall. And maybe move it a little bit to the east. So let's make it 7, say. So it doesn't stick out the far side over there. And give me an orange box. That's looking good. All right. I gave you earlier a clue as to why these textures are behaving so badly. And that is that they break the rules of size. Is it a GLTF here? Yes. Right click, properties, details. One of the dimensions is greater than 1024 and the other is less than 1024. It's 1500 by 1000 roughly. And this is the 1024 by 1024 part of it, or 1000 by 1000 part of it. And this is the part that's not square. So what we can do is just take these images that have this problem. How about these ones here? Oh, silly me. It says if you hover over it, what it is. 1024, 1024. Clearly it's still working because we have branches. And these ones here are just not well sized. So I'm right clicking, open with, and I've installed GIMP, the GNU image manipulation program that I recommend as your image editing tool. It's free. It's a very good editor. And I'm going to simply say image resize, scale image. And this is a little lock indicator indicating that if I change one of the sizes here, the other will keep the aspect ratio. And I don't want that. I want to turn it to a different aspect ratio of 1024 by 1024. You could use 512 by 512 if you want. And even though that like squished it, and you'll find that a lot of the image you want to start with should be rectangular, like you want to make a billboard in the world, and it should be rectangular. You start with a rectangular image, but then you square it to make it a texture, and then your object will stretch that back out on the surface. It works. So I'm going to export this because this regular save is a default proprietary standard for GIMP, but I want to actually get a ping back out of it. It even knows what name I probably want to use. It replaces it. Export. And now Control F5. There it is. Even Explorer needed me to reload. Okay, right click on this one. Open with GIMP. Image resize. No, image scale image. Undo the lock. 1024 by 10. Oops. 1024. I could use 512 by 512. File export. back up over the ping. Export. I'm done in GIMP. And no, I don't want to save to the proprietary standard. And if I hit a Control F5, I think I'll fix the problem with the textures on the tree. Indeed. All right, I'm going to stop there. Well, one more thing. I'm going to stop there, but after just telling you two more things. I'm going to show you how to get the animation in this bird working. It's not a sparrow, by the way. It's a pipit, or a broom pipit. If I have a GLTF already, I can go get the animation names out of it. If I don't, I can pull it into Blender, but be aware of the fact that Blender appends the mesh name on the end of the animation name. So you'd want to look, but then omit that underscore model name. But I can actually look at it in the GLTF if I have the GLTF. You can't do that with the GLB, obviously. But I'll open this with code, search for animation, well down into the file, put my cursor there and search for the first appearance of the word name. And it is fly, very simple. So the animation to make the bird flap its wings is called fly. And so I'm going to the Decentraland docs to get the lines of code to invoke an animation. Handle animations. All right, so we're going to borrow snippets of this code here into our code. I've already made a bird. All right, so I've already done the entity and added the shape to it. So I need this code here. Creating an animator. Add the animator to the bird, not to the shark. The name of the clip is fly. And I think that will do the job. I think the bird will now be flapping its wings. No. I seem to have broken it. F2 to see if it can tell me where. Oh. No. What's the first thing? Iron on base. I think those things are. I think those things are before it's loading the scene. So let me force a reload. See if I still get those errors or a non-flapping bird. If you don't remember, F12 is what opens up this debugging console. Sometimes you can get some information from it. You do need to be on the console tab in here when you're doing that. I think I'm still missing a line of code. Let's go back to the docs. Add clip. Oh, yes. I have to tell it to start. I've set it up, but I haven't told it to start going. You have to play it. clip name dot play is so it is clip swim dot play. And I'm going to rename this to clip fly. Just I propagated that down and go back to my scene. Reload it. Hopefully that fixed it. Oh, am I running the scene? Yes. Yes. So this is a kind of a boring animation because although the animation moves the bird within its own context, you know, it doesn't move it in space, but it flaps the wings. It distorts the mesh is what it does. It has a set of bones in it, a rigging or a skeleton, and the animation moves the skeleton that's built into the Blender file or the GLTF. And then the mesh or the flesh of the animal is associated with the various bones. So when the bones move, then the flesh distorts, the mesh distorts to go with it. You can change the flapping speed. There's a, let me pull this documentation away from the, there's a speed. It is looping. It loops by default, I think. Animation speed. Clip swim. Speed equals 2. I'm going to make it 3. That's about right for this bird. About 3 times as fast as it is. Double click, Control C, double click, Control D. Save. Come back here. Yeah, probably going to be faster than that. All right. So then the other thing I wanted to point out is if you want the bird to move around, you've got to have it fly from place to place using script movement. And I won't take more time right now to show you how to do that. But if you want to do that, the waypoint system, this is part of my DCL Tech library. There's an example there of how to do it. You basically mark certain positions in the scene as the places the thing should move to. And you can control how long it takes to get there and whether it orients toward that when it's going. And if it pauses between, if it waits for you to do an event, like a click on something to make it go. With that, I'm going to wrap today's lesson. See if anybody has any questions. This is a hard lesson. It's definitely the most challenging of the ones that we're going to be doing. And I don't have a hard, like a deadline when you must finish it. If working on this lesson interferes with your working on the game jam, work on the game jam and then come back to this. Perhaps you can even figure out how to do sort of learn from both of them at the same time. But this doesn't have a hard deadline of the end of the month like the game jam does. So there's more value to you in trying to meet a deadline of a scene you design for the game jam right now than to finish this. But I would like you to work on it when you have the time. And yeah, you're welcome, KJ. The game jam is the priority, really. But hopefully this class has taught you how to perform better in it. And I encourage you to work together in teams. And then when you get a chance, come back and finish up this assignment, ask questions. I'm going to keep the course channel open well beyond the like next week. Our last lesson is next week. Our last lesson is not technical. It is all really social. It's encouraging you to create teams, to work on projects, to put out your shingle, create a portfolio. of your work, etc. So these last two lessons, 9 and 10, I'm going to give you plenty of time to finish them. Just keep in touch with me. Try to not to drop them and never get them done. I will provide completion certificates for the people who complete all 10 lessons, all 10 assignments. So with that, I want to thank you all, and we'll be in touch.